Today we are going to talk about the general form of a quadratic equation and what are the techniques which are available to solve a quadratic equation equal to 0. Remember from previous lessons, the general form of a quadratic equation is y is equal to ax squared plus bx plus c, where a, b, c are real numbers and a cannot be equal to 0, because if a is 0, then you're going to end up with bx plus c, which is a linear equation. Now, what techniques can we use to solve a quadratic equation? The first example that I'm going to try to solve is 3x squared plus x minus 2 is equal to 0. Now, as we said before, we are going to group the x terms together, so I'm going to put a bracket around 3x squared plus x. Now I'm going to factor out 3 because the leading coefficient has to be 1, so it's going to be 3x squared plus 1 over 3x minus 2 is equal to 0. Now divide the coefficient of x, which is 1 over 3, by 2. So 1 over 3 divided by 2. Remember, 2 is 2 over 1. Is going to be 1 over 3 times 1 over 2, which is 1 over 6. Square this one. Square 1 over 6 is going to be 1 over 36. So add and subtract 1 over 36. So this becomes 3 open bracket x squared plus 1 over 3x plus 1 over 36. Always remember, you add the first term first and then you subtract again the term. Minus 2 is equal to 0. Now, put a bracket around the first three terms. X squared plus 1 over 3x plus 1 over 36 can be written as a perfect square, which is x plus 1 over 6 squared. If you expand it, x squared is going to be the first term, 1 over 6 squared is 1 over 36, and then 2 times 1 over 6 times x gives you 1 over 3. So this one is correct. Minus 1 over 36 minus 2 is equal to 0. Now expand 3 inside the bracket. I get 3 times x plus 1 over 6 squared minus 3 times 1 over 36 is going to give me 1 over 12 minus 2 is equal to 0. I'm going to bring these two terms to the right. I get 3 times x plus 1 over 6 squared is equal to 1 over 12 plus 2 over 1. Multiply both numerator and denominator by 12. I get 1 over 12 plus 24 over 12, which is 25 over 12, because the denominators are the same, so you just add the numerator. Now I'm going to divide by 3 to get rid of the 3, so I get x plus 1 over 6 squared is equal to 25 over 12 divided by 3 gives you 25 over 36. Now, we know the opposite of square is square root, so I take the square root of both sides. But remember, square root of 25 over 36 is plus or minus. Now, square root of 25 over 36 is going to be 5 over 6. So from here, I get x plus 1 over 6 is plus or minus 5 over 6. There is going to be two solutions depending on if I take the positive root or negative root. If I say x plus 1 over 6 is 5 over 6, I can move this one to the right. I get x is 5 over 6 minus 1 over 6, which is 4 over 6, which is 2 over 3. That's the first solution. Or I can take the negative 0. So I get x is negative 5 over 6 minus 1 over 6, which is negative 6 over 6, which is negative 1. So the roots are 2 over 3 and -1. Now we are going to solve the same equation 3x squared plus x minus 2 equal to 0 with a different technique. Let's say we are supposed to use factoring to solve this one. Since the leading coefficient is 3, we cannot use sum and product method. So hopefully the decomposition method works. So we are going to say AC is 3 times -2, which is -6, and B is 1. Now the question is, find two numbers that the product is -6, but the sum is 1. Those two numbers are 3 and -2, because 3 plus -2 is 1. 3 times -2 is -6. So 3x squared plus x minus 2 equal to 0 can be decomposed into two terms, the x term. So I can write x squared plus 3x minus 2x, this one is going to give you x, which is the same term, and minus 2 is equal to 0. Now I take these two terms together and these two terms together. 3x squared plus 3x, I can factor out 3x, I get x plus 1. Negative 2x minus 2, I can factor out negative 2, I get x plus 1. Now, these two terms, they have x plus 1 common, so I can take x plus 1. I can factor it out. I get 3x from this, and negative 2 from here equal to 0. As I mentioned in the class, when the product of two numbers is 0, either one or both of them, they have to be 0. So from here, I can say x plus 1 is equal to 0, so x is -1. Or 3x minus 2 is equal to 0, so x is 2 over 3. If you look back at the solution that we had before, you can see that the roots are exactly the same. Now we are going to solve the same quadratic equation, but this time using quadratic formula. So in this case, we know that A is 3, B is 1, and C is -2. So our determinant, which is B squared minus 4AC, is equal to B squared, which is 1 squared, minus 4 times A, which is 3, times C, which is -2, which is 1, minus times minus is positive. 4 times 3 is 12, times 2 is 24, so we get 25. 25, because it's positive, we will have two roots, two zeros. So we say that x sub 1 and 2, the two roots are minus b, which is -1, plus or minus square root of the determinant, which is 25, divided by 2a, 2 times 3, which is -1, plus or minus square root of 25 is 5, divided 2 times 3 is 6. If I take the positive square root, I get -1 plus 5 is 4, divided by 6 is 2 over 3. -1 minus 5 is -6, divided by 6 is -1, which is again exactly the same solutions. Now, if we are asked to decide which technique is better, probably quadratic formula is the best technique because it's very fast, straightforward. Factoring is not always possible. Completing squares is very tedious process, and it's easy, you can make a mistake somewhere. And there is another technique which is using technology. If you use sites like Desmos, you can plot the graph of 3x squared plus x minus 2 equal to 0, and then the solution are the zeros or the x-intercepts of the graph. For instance, if we use the technology to plot this graph, you may get something like, let's say, something like this one. This point is -1, and this point is 2 over 3. these are the zeros of the function or the solution. But the graphing is very easy. The only problem is that you have access to technology all the time? And most likely no. So probably the answer to the question is using quadratic formula is the easiest way to solve quadratic equations. One thing you have to remember is that when you look at the quadratic function, the graph of a quadratic function, the zeros are the number of x-intercepts. For instance, as you know, a quadratic function can open up and can open down. If you look at these two quadratic functions, two parabolas, you can see that there is no x-intercepts. So there is no zeros. This is the only possibility for this one to happen is that the determinant, which is d, is less than 0. So when the determinant is less than 0, your quadratic, if it opens upward, it has to be above x-axis. If it opens downward, which means a is less than 0, it has to be below x-axis. And this means that there is no x-intercepts, there is no zeros, or there is no solution to your quadratic function. On the other hand, if you have a quadratic function like this one, which touches the x-axis only once, here a is greater than 0, and here the quadratic touches the x-axis only at that point. This is when a is less than 0. The only way that the quadratic has only one zero or one x-intercept or one solution is when your determinant is equal to 0. And remember, determinant is b squared minus 4ac. If b squared minus 4ac is equal to 0, this means that b squared is 4ac. And then if you want to solve it, you can say that b is plus or minus 2 square root of ac. So the second possibility is that when your determinant is equal to 0, so there is only one solution. And both of them are equal. The last possibility is when, if your quadratic opens upward and a is greater than 0, you have two x-intercepts like this. So this is a greater than 0. Or you can have quadratic that opens downward, meaning a is less than 0. Now, as you can see, for the case a is greater than 0, your vertex has to be below x-axis. In the case that quadratic opens downward, your vertex is above x-axis. In these two cases, you have two zeros or two x-intercepts or two solutions to your quadratic equation. Our next example is the quadratic 4x squared minus 2x plus 10 is equal to 0. The question is, how many solutions does this equation have? The easiest way is to determine the determinant. So I'm going to say a is 4, b is negative 2, and c is equal to 10. D is b squared minus 4ac, which is b squared negative 2 squared minus 4 times a, which is 4 times c, which is 10. Now, negative 2 squared is 4. Negative 4 times 4 is negative 16 times 10 is negative 160. You can see this is negative 156, which is less than 0, so there is no solution, no zeros, or no x-intercepts here. The next example is to find the number of solutions to equation 4x squared plus 4x plus 1 is equal to 0. Again, A is 4, B is 4, and C is 1, so D is B squared minus 4AC, which is 4 squared minus 4 times 1. Now 4 squared is 16, minus 16 is going to give you 0. Since our determinant is 0, there is only one solution. Although when you solve it, you will get 2 solutions, but both of them are equal. Our last example is x squared plus x minus 6 is equal to 0. You have to find how many solutions are there. Again, A is equal to 1, B is equal to 1, C is negative 6. So D is B squared, which is 1 squared, minus 4 AC, which is 1 times negative 6. 1 squared is 1, 4 times negative 6 is negative 24, times 1 is negative 24, times negative 1 is plus 24, which gives you 25. Since 25 is greater than 0, we say that there are 2 solutions here.